Welcome to our presentation by the team Class C. Me, myself, Muralidhar Kolimali, and my teammate Geetha Prasanna Sunkara under the guidance of Professor Shivanjali Kare. Our project is A journey through alpha-beta pruning in chess, where we signify the focus in building the chess playing AI using advanced algorithms. When we speak about how the game works, basically the chess is a two-player strategy game. Oh, but here one player will be the user and other one will be the AI. And the chess is a basic 8 by 8 gridded board with a alternate pattern of light and dark. When the main objective of the game is to checkmate our opponent's king while defending our own king. When we talk about the requirements for this project, we mainly need the Python version 3.10 or the new one. And when it comes to the libraries, we use it the libraries like Pygame, which is an open source library. We use it for rendering the graphical interface and the time module for measuring execution efficiency. When we speak about how the chess pieces move, the main part of the chess is the king, where the king can move in only one direction, in any direction, but it can only move one square, whether it can be horizontal, vertical, or diagonal. When it comes to the queen, it is the most powerful piece in the chess due to its ability to move any number of squares in any directions, whether it's horizontal, vertical, or diagonal. When it comes to the rook, it's the second most powerful after the queen. It can move like the queen, but it can't move diagonally. When it comes to the bishop, it has a unique movement. It means it's limited. It's not limited of spades, but it's limited in its own color. When it comes to the knight, it moves in an L shape and has the special ability to jump over the other pieces. And the last one is the pawns, which can move only one space forward unless it's their first move, where in their first move they can move two squares. Oh, when we speak about the files, we have in our project we have uh, divided the project into modules where we created assets called a chess.py, pieces, board, user interface, and queen.py, where the chess.py is the main executable file that launches the game. The pieces.py defines movement behavior for all the pieces. Board.py contains the core logic and the beta pruning implementation. And the user interface handles the game rendering and the user interface which is started with the Pygame. And the AntQueens implements and visualizes the AntQueen solver using the recursive backtracking. Additionally, we used an assets folder which is used to store the graphical elements like chess piece images. The modular design keeps the code base organized and easy to maintain and extend. The main objective of our code is to develop an intelligent interactive chess game powered by artificial intelligence. Our team seeks to create a system that simulates strategic gameplay, poses a genuine challenge to human players, and is responsive and accurate in decision making. The project explores and compares mainly three algorithms, which is the alpha-beta pruning, A3C, which is a reinforcement learning method, and the end-to-end solver to determine optical move logic and algorithm efficiency. As we speak, we have used mainly three algorithms, which is the first one is the alpha-beta pruning. Uh, Alpha-beta pruning is described as an enhancement to min-max that reduces unnecessary computations by cutting off suboptimal paths in the game tree using alpha-beta bounds. The alpha gives the best score for the maximizing player, and the beta gives the best score for the minimizing player. And it prunes the branch that cannot influence the final decision. In this, the outcome will allow the AI to compute moves faster while maintaining the accuracy. And the second one, the A3C or the asynchronous advantage arithmetic. The main purpose reinforce is to achieve reinforcement learning using simple multiple game instances currently. It isn't it helps the AI to learn faster and develop strategies by evaluating the outcomes. The main outcome is it speeds up the AI's learning progress. And the end queen, it's a recursive backtracking algorithm. It is used to explore the possible queen placements row by row. After each step, the queen can be safely placed in a column. If a full arrangement is valid, it is saved and displayed using Pygame.
The methodology outlines the development approach. The first step is move generation implemented using a object-oriented program to module how each piece behaves. Alpha-beta pruning is then used to build a decision tree and then evaluate moves up to a fixed depth, optimizing for the best outcome. A3C is employed for the self-learning where the AI plays against itself to adapt over time. The n-queen algorithm is used to validate the implementation of the recursive and the search-based logic. Together, these methods ensure the system is logical, static, and capable of learning. The evaluation, this slide discussing how the project is tested for the effectiveness. Adaptability is measured using the self-play, allowing the AI to refine its strategy through the repetition. Move accuracy is compared across the three approaching alpha, beta, A3C, and N-queen to evaluate the decision-making quality. All through N-queen is not used for the chess moves. It helps verifying the correctness of the search-based logic. User satisfaction is measured by the how quickly the AI responds and how smart its decision seems to human players. These multi-dimensional evaluations ensure the AI performing well both logically and interactively. The deliverables section outlines what the project has produced. It includes a working chess application with AI opponent logic, a clean and well-documented source code repository in GitHub, detailed documentation that explains how to install, train, and use the system, and a video demo available on YouTube. These deliverables ensures that the project is not only technically complete, but also user-friendly and easy to present to expand in the future. And the output, the detailed outputs results shown on the slide, it represents the successful completion of the AI and n-queen solver. Thank you. Now let us try to run the code in order to see the output. Firstly, open the new terminal. And after that, give a command user interface Python chess.py. So here, each possible moves are represented as a tree. Each nodes represented potential game split result from the module. After that, AI tries to achieve best possible advantage in the branch of the tree. Source worst in the alpha for the AI, the worst in the beta for the opponent. The branch is upper hand. Now try to move the node after black is turned on. If you move this white one, back will turn on. And if you move this one, and if you want to try this one, the move is invalid or unsafe. That means this move, we can't able to move forward. It is invalid and unsafe. If you move this one, it's unsafe. It will turn, black will turn on. See? Python program and choose the n-queen solver by entering the n-queen. Then we prompted from the size of the board is 8. And here it's showing like how many possibilities we have. How many possibilities we have to place a queen. Now, here it's showing like a displayed 92 solutions. It means 8 queens problem finds all 92 ways to place 8 queens on the 8 into 8 board. So no two than each other. Each solution places one queen per row in a unique column, avoiding the conflicts across rows, columns, and diagonally. Finally, the player moves a response immediately, showcasing its station making capabilities during this game playing. The AA output performance matrix such as how quickly the AA makes decision and also of the quality of the moves based on the evaluation of the book state. Thank you all.